Hello everyone, my name is Dhangar and today I will be demonstrating my digital system design project automatic washing machine controller implemented using Verilog HDL. This project implements a finite state machine that controls all operations of a washing machine including water filling, detergent addition, washing cycles, draining and spinning. The unique feature of this design is the pause resume mechanism that allows user to temporarily halt operations and continue from exactly where they stopped. The washing machine controller is designed as a Murray type finite state machine with 7 distinct states: check door, fill water, add detergent, cycle, drain water, spin and pause. Let me explain the operation flow. Check door. This is our initial state where the system waits for the user to close the door and press start. Fill water. Once started, the water inlet valve opens to fill the tank. Add detergent. The system dispenses detergent for the soap wash cycle. Cycle state. The monitor agitates the perform the washing action. Drain water. The drain valve opens to empty water. And spin. High speed rotation to extract remaining water. Pause state, our special state that allows user to pause the operation at any time. The controller performs two complete wash cycles. First, a soap wash with detergent, followed by a rinse cycle with clean water. This ensures through cleaning and proper rinsing of clothes. Let me highlight the key features of this design. First, it uses synchronous sequential logic with single clock domain, making it reliable and easy to implement. Second, the design includes comprehensive safety mechanism. The door remains locked throughout the entire operation to prevent accidents. Third and most importantly, our pause resume feature. This uses a special save state register that captures the current state when the user presses pause. When they press resume, the system returns exactly to that saved state and continues operation seamlessly. Fourth, all outputs are controlled independently: motor, water inlet valve, drain valve, and door lock, providing precise control over each actuator. The system uses 3-bit state encoding, which efficiently represents all 7 states while leaving room for future expansion. Now, let's look at the Verilog implementation. We have used EDA Playground for Verilog simulation. The module has 11 input signal including clock, reset, various sensors and pause resume buttons. It generates 7 output signals to control the washing machine actuators. Here you can see our 7 state encoded in 3 bits from 000 for check door to 110 for paused. This combinational always block implements the core FSM logic. It uses a case statement to determine the next state based on the current state and input conditions. Now notice how each state check if pause button is pressed. This allows pausing from any operation. This sequential block updates the state register on every positive clock edge. It also implements asynchronous reset and crucially saves the current state to saved state register when pause is pressed. Here's the key pause resume logic. When pause button is high and we are not already paused, we save the current state. When resume button is paused, from pause state, we transition back to that save state. This elegant design ensures the washing cycle continues exactly where it was interrupted. Now let's see the design in the action through simulation. This is the complete waveform generated by our test bench. Let me walk you through what's happening. At time equal to 0, reset is asserted, initializing the system to check door state, which is binary 000. At t equal to 100, we see start and door close signal go high. The state immediately transition to fill water. And notice how door lock signal goes high. The door is now locked for safety. During fill water state, the fill valve on signal is high, indicating water is flowing into tank. At t equal to 200, the field signal goes high and we transition to add detergent state. The soap wash flag is now set to 1, indicating this is the soap wash cycle. At t equal to 300, after detergent is added, we enter the cycle state. Look at motor on signal. It goes high, meaning the motor is now agitating the clothes. Now here is the most interesting part. At t equal to 350, watch what happens when we press the pause button. The state changes to paused and immediately motor on signal goes low. All valves close, but notice door lock remains high. This is critical safety feature. The system stays in pause state until t equal to 550. When we press resume button, now watch the state returns to cycle. The motor on signal goes high again and washing continues exactly where it stopped. This is our pause resume mechanism working perfectly. Continuing through the simulation, at t equal to 700, the cycle timeout occurs and we transition to drain water. The drain valve on signal activates. Once drained, the system automatically goes back to fill water. For the rinse cycle, notice water wash flag is now 1, indicating this is the rinse cycle, not soap wash. Finally, after the rinse cycle completes and water is drained, we enter spin state. At t equal to 1200, spin completes and system returns to check door state, with the done signal set to 1, indicating successful completion. Throughout this entire operation, you can see that door lock remained high until the very end, ensuring user safety. Let's also look at the console output from our simulation. The test bench prints the state and all output values at every clock edge, giving us detailed trace of the operation. You can see here at t equal to 350, state equal to 010, which is detergent added state, and after that t equal to 400, state equal to 011, when motor is 1, actively washing. Then t equal to 450, state equal to 110, paused, motor drops to 0, operation halt. At t equal to 650, back to the state cycle 011, motor returns to 1, operation resumed. This textual output complements the waveform and provides easy verification of correct behavior. In conclusion, this project successfully demonstrates the design and implementation of an automatic washing machine controller using Verilog hardware HDL. We have achieved a complete functional FSM based controller, an innovative pause resume feature, comprehensive safety mechanism, verified operation through simulation, a scalable design ready for real world implementation. This project has provided valuable hands on experience in digital system design, hardware description language coding, finite state machine implementation, and verification techniques.